All right, so first step is x squared minus 4 equals 0. X squared equals 4. X equals plus or minus 2. So the domain is all real numbers, but x cannot be positive or negative 2. Agree with that? Okay. Step 1.5 says I need to take this and I can make this be 2 times x minus 3 and x plus 3 and put that all over x minus 2, x plus 2. Agree? Nothing cancels out, correct? Okay. So since nothing cancels out, move all this stuff. Come on, catch it, didn't catch it. Move all this stuff up. So since nothing cancels out, my vertical asymptotes are still x equals 2 and x equals negative 2. Those didn't change. Agreed. Okay. Step number 2 says I need to find my horizontal asymptote. Degree of the numerator is 2. Degree of the denominator is 2. So those are the same, so I look at the lead coefficients. Lead coefficient of the numerator is 2. Lead coefficient of the denominator is 1. So my horizontal asymptote is y equals 2. Okay. Then step 3 says now I need to find my y-intercept. So that means I find f of 0. That's going to be 2 times 0 squared, which is 0, minus 9, all over 0 squared, which is 0, minus 4. So that's going to be negative 18 over negative 4, which simplifies down to positive 9/2. So my y-intercept is at 0, positive 9/2. Agree with that? Okay. Step number 4 says I need to set the numerator equal to 0 and solve for my x-intercepts. So that's going to be x minus 3 equals 0. So that's x equals 3. X plus 3 equals 0. So that's going to be x equals negative 3. So those two give me my x-intercepts of 3, 0 and negative 3, 0. Did anything cancel out when in step 1.5? Nothing crossed out in step 1.5, so therefore there is no hole. Okay. So that then allows us to go to the graph now. So I need to have a vertical asymptote at positive 2 and at negative 2. I need to have a horizontal asymptote at positive 2. Adjust those a little bit here. That one there. That one there. Okay. That means I get to have a y-intercept at 0, 9/2. 9/2 is 4 1/2. So that's right there. And I get to have an x-intercept at 3, 0, and negative 3, 0. No hole to speak of. So now I just have to come up with other points that fit into this particular graph. So, because, a little side note, a little math logic note, because both x's, or all of the x's in this problem, are squared, that means that if I plug in negative 4 into my function, I'm going to get the same value if I plugged in positive 4, because everything's squared. If there was just a singleton x in there, like if there was a plus 3x somewhere in this problem, that was not possible. But everything is squared, so if I plug in positive 4, I get the same as if I would plug in negative 4. Okay? So, down here, if I plug in, let's plug in 4, in fact. Oops, that should have been black. It's not all the way down. There we go. So if I plug in positive 4, I get 4 squared, which is 16, minus 9, which is 7, times 2, which is 14. On the bottom, I get 4 squared, which is 16, minus 4, which is 12. 14 over 12 simplifies to 7/6, which is just a little bit more than 1. So on both 4 and negative 4, we get that. If I plug in 10, 10 squared is 100, minus 9 is 91, times 2 is 182. 10 squared is 100, minus 4 is 96. Okay? That is just a little bit smaller than 2. I think it's like 1.9, figure it out for me please, 182 divided by 96.
1.8958.
So like 1.9ish, yeah. Okay, so just a little bit under. Okay? Then I have to do my middle section. Plus and minus 1. 1 squared is 1, minus 9 is negative 8, times 2 is negative 16. 1 squared is 1, minus 4 is negative 3. Negative 16 divided by negative 3 is a little bit more than 5. It's actually 5 1/3. So I'm up there on both sides. Okay. That now is enough to draw in my function. So we go here and down. In the middle section, it's parabolic. And over here and down. Okay. Now, this particular problem did not ask for end behavior and asymptotal behavior. However, if it were to ask for it, hint, hint, wink, wink, nudge, nudge, your quiz tomorrow, okay, I would say as x goes to positive infinity, my function approaches 2 from below. As x goes to negative infinity, my function approaches 2 from below. That's my end behavior. My asymptotal behavior, as x approaches negative 2 from the left, my function goes to negative infinity. As x approaches negative 2 from the right, my function goes to positive infinity. As x approaches positive 2 from the left, it's going to positive infinity. And as x approaches positive 2 from the right, my function is going to negative infinity. Okay. Questions on this example? Okay, let's do another one in your groups. Let's do this one. Sketch this graph, include any intercepts, asymptotes, and holes, and all that fun stuff. Yeah, you paid up a year later.
Did you go?
Okay, so first off, first step, I say x squared plus 4x minus 5 equals 0. That factors to be x plus 5 and x minus 1. So then that makes x plus 5 equal to 0. So that's going to be negative 5. And x minus 1 equals 0. It's going to be 1. So my domain here, agree. Okay. Step 1.5 says that I can factor a 4 out of the top. My bottom factors to be x plus 5 and x minus 1. So the x minus 1 cancels out. That tells me what?
There's a hole.
That there's going to be a hole. Okay? As soon as I cross something out there in step 1.5, that makes step 5 active. If I don't cross anything out, I can skip step 5. Okay? So f of x here from now on is 4 over x plus 5. Which means that my vertical asymptote is only x equals negative 5.
Okay, so after you find the domain, you always use the second equation.
Yep.
For the rest of the time.
Rest of the time. Degree of the top is 0. Degree of the bottom is 1. Horizontal asymptote is y equals 0. Did you even do this problem yet? Did you do the graph? Then let's focus on that instead of focusing on having social hour. Okay? Step 3, f of 0 is going to be 4 over 0 plus 5. That's going to be 4/5. So my y-intercept is 0, 4/5. X-intercept, 4 equals 0 can't happen. So there is none x-intercepts. Hole. We crossed out x minus 1. So I set x minus 1 equal to 0, and that gives me x equals 1. So the hole is going to be at 1, something, and that something I put 1 into my function. 4 over 1 plus 5 is 4 over 6, which is 2/3. So my hole is at 1, 2/3. Okay. So let's go put all that stuff onto our graph now. One, 2, 3, 4, 5 is my vertical. Y equals 0 is my horizontal. Let's fix those. Y-intercept of 4/5. X-intercept of none. Hole of 1, 2/3. Okay, so we're good there. Then if I do extra points, if I plug in -4, I get +4. So I'm right there. If I plug in -3, I get +2. So I'm right there. If I plug in 10, I get 4/15, which is actually right there. Okay. If I plug in -6, I get -4. -7 is -2. -9 is -1. So my graph comes here. Graph comes here. I stop, lift up, come to the other side, and there it goes. Okay. And behavior, as x goes to infinity, my function approaches 0 from above. As x approaches -infinity, my function approaches 0 from below. Asymptotal behavior, as x approaches -5 from the left, my function goes to -infinity. As x approaches -5 from the right, my function goes to positive. But that was extra, so we didn't have to do that. Okay? So, yellow homework packets are due tomorrow. Quiz is tomorrow. 2 problems, front and back, this time instead of top and bottom. Okay?